Hi, everybody. Welcome to Math with ACE. We're doing statistics with ACE today, and we're focusing on normal distributions. There are a variety of ways that you can calculate probabilities with normal distributions. You can use a Texas Instruments calculator. You can use Excel. You can use tables in the back of your textbook. You can use tables that are online. I'm going to use Statlet. It's a free resource online. It's an applet that allows you to use a normal distribution calculator to perform these operations. And so that's what I'm going to be using. I will show you the different screenshots of what that would look like in Statlet and how to enter the information. But essentially what we're going to do is we're going to practice how to perform these calculations when asked, okay? So first, we're told, suppose X squiggly line n 5, 6. What does that mean? That is saying we're talking about X, which is normally distributed with a mean of 5 and a standard deviation of 6. So we need to be able to interpret what that means to begin with. What is the z-score for the value x equals 17? And what is the z-score for the value x equals 1? We need to know the z-score formula. For populations, the z-score formula is the mean is the value minus the mean divided by the standard deviation. You always do the value first, because if the value is larger than the mean, you need a positive. And if the value is smaller than the mean, you need a negative. And in order for that to happen, the value has to come first. So the z-score for x equals 17 is found by taking 17 minus the mean of 5 and dividing by the standard deviation of 6. It is critical that you either do this in 2 steps or you put parentheses around 17 minus 5. If you do not, your calculator is going to divide 5/6 and then take that away from 17, and you will not be correct with your answer. Okay? 17 minus 5 is 12, divided by 6 gives me a z-score of 2. That is 2 standard deviations above the mean. The z-score for a value of 1 is 1 minus 5 over 6. 1 is below 5, so my fraction better be negative. 1 minus 5 is negative 4. Divided by 6 gives me a fraction that is negative 2/3, or if you're rounding to decimals, you'd get 0.667. I like to go to 3 decimal places here. Okay. In our next example, we're going to be filling in some blanks. Some doctors believe that a person can lose 5 pounds on average in a month by reducing their fat intake and by exercising consistently. Suppose weight loss has a normal distribution. It's really important that we read that somewhere in our work. Otherwise, we don't really know which calculator to use. So X is the amount of weight loss in pounds by a person in a month. Use a standard deviation of 2 pounds. And then we're also told X is normally distributed, and they call back that 5 pounds. So they believe 5 pounds on average. That keyword here told us the average was 5, and then they told us the standard deviation was 2. Suppose a person lost 10 pounds. That's more than the average. The z-score when x equals 10 pounds is 2.5. Let's verify that. I take the value of 10 minus 5, and I divide it by the standard deviation of 2. 10 minus 5 is 5 divided by 2, and 5 divided by 2 is 2.5. This z-score tells you that x is, well, what is the z-score? Because z-scores are measured in standard deviation. The z-score was 2.5, so this tells us that x equals 10 is 2.5 standard deviations to the right is positive, left is negative. To the right of the mean, which is 5. Okay, so now a person gained 3 pounds, which is on a chart of weight loss the wrong way. So z is 3 minus 5 divided by 2. 3 minus 5 is negative 2. Divided by 2 is negative 1. So that is negative 1 standard deviations. Sorry, I wrote it in the wrong spot. The z is negative 1, and that tells us it is negative 1 standard deviations to the left of the mean. Negative is to the left, positives are to the right always. Suppose the random variables x and y follow normal distributions where x was 5, 6 and y is 2, 1. If x is 17, then z is 2, as above. X is 17 and z is 2. If y is 4, what is z? So now we're referencing these numbers to calculate a z-score. Z equals the value minus the mean divided by the standard deviation. So the z for when y equals 4 is equal to the value of 4 minus y's mean is 2 and the standard deviation is 1. And I know that because the first number is the mean and the second number is the standard deviation. So 4 minus 2 is 2. 2 divided by 1 is 2. So both of these calculations provide a z-score of 2, but both have different means and different standard deviations. So what that's saying is one is more spread out than the other. A larger standard deviation means the distribution is more spread out on a number line, but they still both have the same z-score. So you can compare z-scores across distributions. Okay, let's fill in a couple more blanks before we get into calculations. The mean height of 15 and 18-year-old males from Chile from 2009 to 10 was 170 centimeters. Where's the mean? There you go. And a standard deviation of 6.28 centimeters. Male heights are known to follow a normal distribution. Okay, we're good. Let X be the height. Then X that follows a normal distribution with a mean of 170 and a standard deviation of 6.28. Absolutely. Suppose a 15 to 18-year-old was 168 centimeters tall. Then what's the z-score? Well, z is the value of 168 minus the mean of 170 divided by the standard deviation of 6.28. So I do 168 minus 170. It's a negative because that's less than the mean. Divide that by 6.28 and I get negative 0.318. So the z-score tells us that x equals 168 is negative 318 standard deviations to its negative. So we are left of the mean, which was 170. Suppose the height has a z-score of 1.72. What is the male's height? Now we're going to go backwards. Okay, so if z equals the value minus the mean over the standard deviation, I fill in what I know. I know that z is 1.27. I don't know x, but I know the mean is 170 and the standard deviation was 6.28. So in order to solve this equation, I reverse the order of operations. I am going to multiply both sides by 6.28 first. So 6.28 times 1.27 is 7.9756, and that equals the value minus 170. Add 170 to both sides. So the male's height here is 177.976. The z-score tells you that the male's height is 1.2 standard deviations to the positive means right. So we calculated a value from a z-score. It's an inverse of using a z-score. Okay, come back to our next video where we're going to use technology.